Welcome to AWS VPC Advanced Architecture section. In this section, we'll continue discussing VPC. We'll talk about VPC connectivity options. We'll talk about VPC usage patterns. We'll talk about something called dedicated instances, whereby we can request all our instances to be run on a dedicated physical hardware in AWS. Next, we'll talk about connecting our corporate data center to AWS. Next, we'll put together all the components we learned in this section together. We'll discuss the VPC connection limits and the pricing of VPC, and then we'll summarize VPC service. So we learned so far that when we create VPC, we create a public subnet, or we can create a private subnet. This is one of the most popular options of VPC. And typically when we design this VPC architecture, store our databases and batch processing applications or the services that don't need to be exposed to the internet in the private subnet. And in the public subnet, we keep our web servers or services that need to be exposed to the internet. Next, let's talk about the routing between the subnets that we created. So on the top, I have a public subnet, subnet number 1, and at the bottom of the screen, we have subnet number 2, which is a private subnet. And they can communicate with each other because when we create this VPC, Amazon automatically creates a routing rule for us. All the instances in the same subnet will be able to talk to each other because of this default routing rule Amazon puts it. So as long as we are in this network 10.0.0.0, any instance can talk to each other as long as the routing rules allow it. So what about internet connectivity? So now if you want to have our public instances, in this case, the EC2 instance on the top, on this public subnet wants to talk to the internet, it needs to have two things. It needs to have an elastic IP or a public IP assigned to that instance, and it needs to have an internet gateway before it can communicate with the internet. So the default routing rule, now the routing rule for the public subnet on the top subnet will look like this now. We have the original routing rule that it can communicate with instances in the same VPC, but now we have a new routing rule which says the default routing rule or default gateway for the subnet is the internet gateway ID that we just created. But the instances in the private subnet still don't have internet connectivity. We'll figure out in the next step how to resolve that issue. Now in the previous slide, we saw when we create this internet gateway, our routing rule gets changed. We add this default gateway or default router of 0.0.0.0, which essentially means anytime these instances on the public subnet, on the top level on the public subnet on the top wants to communicate with the internet, they go through this internet gateway. So to resolve this issue, we have to create a separate dedicated instance called NAT instance that can be used as a default gateway for the instances in the private subnet. So now the public subnet has access to internet connectivity because of this routing rule for using our internet gateway. Now for the private subnet instances, we have added a new routing rule, which says, so the default router or default gateway for the instances in the private subnet is the NAT instance ID we created. So this NAT instance, if you see it, is in the public subnet, and because it's in the public subnet, because it has a public IP address, and because this NAT instance is in the public subnet, because it has a public IP address, it can accept traffic from the instances in the private subnet and route it to the internet through the internet gateway. Again, to summarize, the instances in the public subnet, instance number 1 and instance number 2, can talk to internet using the internet gateway because that's the default gateway we specified for this subnet. The instances in the private subnet, instance number 1 and the database DB master that we are denoted here, can talk to internet using the NAT instance gateway. The NAT instance is a special device, special EC2 instance that we had to create, and it accepts the traffic from the instances in the private subnet and then routes the traffic over to the internet using the internet gateway. So the routing rule for the routing table for the public subnet looks like on the top, and the routing table for the private subnet is one on the bottom. Now we also talked about the ability for us to extend the corporate data center into AWS to connect using a secure VPN connection between AWS and corporate center using these two components called virtual private gateway and customer gateway on the customer side. We use these two components like virtual private gateway and customer gateway to establish this secure connection to extend this data center into AWS. Now, how does the routing table look like for this connection? So now if you look at the routing table for this subnet, this is called a VPN only subnet because this is not a public subnet, this is not a private subnet, and the only way for this connection, the only way for the instances in this subnet to talk to the internet is through this secure VPN connection. So now if you look at the routing table for this subnet, VPN only subnet, it has the default router or 0.0.0.0/0 points to the VGW ID or the virtual private gateway ID that we create on the Amazon side. So the internet connectivity or the connection, outbound connection for these instances in the VPN only subnet is through this VPN link only. So we talked about hybrid architecture of how we can connect using how we can extend our data center and how we can make our application in the cloud access secure databases in our data center using this VPN connection. So if your customer has multiple data center, how do we connect using the virtual private gateway? In this case, we have a customer who has a data center in LA, in Chicago, and New York, and Miami. And we can use the same virtual private gateway to establish multiple VPN connection to all their data centers. So this diagram shows all the three different types of subnets we talked about. Subnet number 1 is a public subnet, so the routing table for that subnet shows Internet Gateway as the default router for that subnet. Subnet number 2 is a private subnet, and it does not have a NAT instance ID in this case, but you could add a NAT instance ID for this subnet and route the traffic through that one. Subnet number 3 is a VPN only subnet, and the only connectivity for these instances is through this VPG gateway or virtual private gateway ID specified here. When you want to create a new VPC in AWS, Amazon gives you 4 different choices. So the first choice we want to talk about is a VPC with a public subnet only. As you can see in this diagram, there's one public subnet that's created, and it has the connectivity to internet. You can access all the internet services plus the other AWS services such as S3, EC2, and SimpleDB over the internet connectivity. So this is the option number 1, again, is VPC with a public subnet only. The second option is to create a VPC with a public and private subnet. You can create more than one public subnet or more than one private subnet. In this case, you have a NAT instance that the private instances can route the traffic to the internet, and the public subnet obviously has access to the internet. The third option is to create a VPC with a public subnet, private subnet, and also include a hardware VPN that connects back to our data center. So this is usage pattern number 3, the VPC with a public, private subnet, and a hardware VPN connection back to the data center. Option number 4 is to create a private subnet, completely secure, completely isolated network within the public cloud, and the only connectivity it has to the world is through this VPN gateway. Next, let's talk about dedicated instances. If you want to improve the security further, you can use something called a dedicated instances. When you choose to use dedicated instances, the instances that Amazon allocates for you are physically isolated at the hardware level. That means other customers' instances will not run on that physical hardware. This option is only available in VPC. You can choose the dedicated instance option when you launch an instance, or you can set it up at the subnet level. So that means all the instances in the subnet will be a dedicated instance. Dedicated instances, you are paying an additional fee of $2 per hour on top of the normal EC2 charges, because Amazon is dedicating that physical hardware for your account. Again, it does not mean that there's a one-to-one correspondence between the instance and the physical hardware. All that means is on that single physical hardware, other customers' instances will not be started. When you're creating a VPC, this is the VPC. When you're creating VPC in the wizard, it gives you an option of hardware tenancy. You can choose you can leave it at the default tenancy, which means it's a shared resources. Other customers' account can be created on this physical hardware, or you can choose to use dedicated instances. That means the other option is when you start a new instance, when you're starting a brand new instance, you can choose you can look at the tenancy option when you're creating a new instance, and you can make that a dedicated instance at that time. So there is no additional cost for using VPC. There are certain limits though that Amazon imposes on us. By default, we can create 5 VPCs per regions. You can create 200 subnets per VPC. You're allowed to create 5 internet gateways per region. You're allowed to create 100 virtual private gateways per region, and you're allowed to create 100 security groups per VPC, and you're allowed to have 5 elastic IPs per region. Some of these limits are soft limits. In other words, if you require additional resources, for instance, let's say you need more elastic IPs in the VPC region, you can call Amazon, you can submit a form, and with proper justification, they will increase the number of elastic IPs you can use in a region. In summary, we learned that using VPC, we can create an isolated private environment in public cloud. We have more control over our networking and security aspects in this environment. We are allowed to create private subnets, instances that are not internet addressable by default. We can create public subnets for the services that need to be exposed to the internet. And as we learned, there are several security mechanisms or security tools that are at our disposal, such as network access, routing tables, NAT devices, and the security groups that we used in the previous sections. In addition to that, we can use dedicated instances to further secure our environment.